Hello students, welcome back to JJ's physics class. I hope that all of you are doing very well. Today we will be discussing about distance time graph. To describe the motion of an object, we can use line graph. So distance time graph for accelerated motion. This table shows the distance traveled by a car in a time interval of 2 seconds. That means when the time is 0 seconds, distance is also 0. When the time is 2 seconds, distance covered is 1 meter. When the time is 4 seconds, the distance covered is 4 meter. When the time is 6 seconds, the distance covered is 9 meter and so on. So let us start plotting the graph. So for plotting graph, first we need to have the graph sheet, and since we have the values given here, we have to choose the x-axis values and the y-axis. This is the x-axis and this is the y-axis. Time is independent quantity and distance is dependent on time. So independent quantities we always plot on the x-axis. That means time in second is on the x-axis and distance in meter is along the y-axis. Before plotting the graph, first we need to fix the scale. That means the scale on x-axis is starting from 0 to 12 seconds. So easily you can choose a scale on x-axis as 1 centimeter. So this distance gives you what? 1 centimeter. So 1 centimeter is 2 seconds. So scale on x-axis 1 centimeter is equal to 2 seconds. That means next will be 4 seconds. Next will be 6 seconds. Next will be 8, 10, 12, 14, etc. But on the y-axis, as you can see here, the initial value is 0, but the final value is 36. So we cannot choose 2, 4, 6, 8, 10, etc. because this scale won't fit in this y-axis. So we have to choose the scale in such a way that y-axis 1 centimeter is 5 meter. That means 5, 10, 15, 20, 25, 30, 35. That is the y-axis. That means you can plot all the values, that is from 0 to 36 on the y-axis. So here we have taken the scale on x-axis. 1 centimeter is 2 seconds interval and scale on y-axis is 5 meter interval. Let's start plotting the graph. So as you can see here, the first value is for 0 seconds, the distance is covered also 0. So distance is 0 and the time is also 0. So we can see that the first point is somewhere here. Next is for 2 seconds, the distance covered is 1 meter. So for 2 seconds, so the time is 2 seconds here and the distance covered is 1 meter. As you can see here, the interval on the y-axis is 5 meter, 10 meter, 15 meter. That means 1 centimeter is 5 meters. So how the scale goes on? So this will be your 1 meter. This will be 2 meter. So 3 meter, 4 meter and 5 meter. So it goes like that. 1 meter on the y-axis and 2 second on the x-axis. So here we get the next point. Okay. And for 4 seconds, the distance covered is also 4 meter. So as you know that 1 meter, 2 meter, 3 meter, 4 meter. So 4 meter somewhere here and the distance covered is 4 meter and the time is 4 seconds. So the next plot is here. Next is 6 seconds, 9 meter. So 6 seconds, 9 meter. So this goes like this. Okay, 6 meter, 7 meter, 8 meter. So this will be your 9 meter. So 9 meter, the point is here. Okay. Next is 8 8 seconds 16 meter. So 8 seconds 16, so this is 15 now, so this will be your 16 meter and this will be your 8 seconds. Okay, so the next point, so draw these two lines where these two will meet, so you get a point here. Okay, next is for 10 seconds the distance covered is 25 meter, so 10 second is here. Okay, and 25 meters, so you can directly plot the point here. For last point 12 seconds the distance covered is 36, so this is 35, so this will be what, 36 meter, so 36 meter and 12 seconds, so the last point is here. Okay, so this is how you must plot the graph. Now draw all the points here so that you get the nature of graph like this. As you can see that the nature of graph is not a straight line. So this graph represents motion with non-uniform speed. Thank you, students.